Hello everyone. In this video, I'll be addressing multiple choice question related to the subject of linear algebra in engineering mathematics. Uh, my prime focus is to discuss a problem or within the subtopic of the rank of a matrix, linear dependent and independent vectors, solution of linear system of equations, inverse of a matrix, eigenvalues and eigenvector, and Cayley-Hamilton theorem. So let us start with the problems. Okay, so the very first question is we are given a matrix A and the question is we want to find out the rank of a matrix. So we are given these options. The same question asked in the GATE examination in 2003. Let us see that how can we find out the solution of this problem. So in this case, if we just look at this matrix is a rectangular matrix which is of order. It has the 3 rows and it has 4 columns. You can see here it has the 3 rows and it has 4 columns. So because it is a rectangular matrix, so according to the property of a rank of a matrix, the rank of a matrix is always less than or equal to the minimum of the number of rows or the number of columns. So from here we get an idea that the rank of the matrix is less than or equal to 3. So to find out the rank of this matrix, so we are going to apply here the concept of row echelon form. We'll try to reduce the given matrix into row echelon form to find out the rank of a matrix. Okay, to find out the rank here, so firstly we consider matrix A, whose elements are 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. So the first step is we are going to interchange first row with the third row. So that we'll try to make this as a pivot element, okay, as a first element of the first row. So when we interchange this row, then we get the first row elements are 2 1 0 1, no change in the second row element 6 3 4 7, and now third row element will be 4 2 1 3. So to reduce this matrix into row echelon form, the first step is we'll try to make these two elements 0, right? So when we'll try to reduce this element 0, we firstly try to make this element as the identity element, because if this element is 1, then we can easily reduce this element to 0. But in this case here, the first entry is 2, which is already here 4 and 6, they are already multiple of 2. So we can easily reduce them to 0. So we are going to apply the operation to make this entry 0. So we are going to apply operation R2 minus 3 times R1, right? Because when we take 3 times R1 and it becomes 3 into 2 is 6, this is 3, this is 0, and this is 3. Okay, so if we apply this operation, then there will be no change in the first row element 2 1 0 1, and your second row element 6 minus 6 is 0, 3 minus 3 is again 0, 4 minus 0 is 4, and 7 minus 3 is 4. So these are the element of this second row. Now we are going to apply the operation on a third row. So for third row here, the entries are 4. To make this element 0, so we are going to apply the operation as R2, R3, R3 minus 2 times R1. So we apply this operation, then what will happen? So 2 into 2 becomes 4, this is 2, this is 0, and this is 2. So now clearly 4 minus 4 is 0. So your third row element become 4 minus 4 is 0, 2 minus 2 is again 0, 1 minus 0 is 1, and 3 minus 2 is 1. So now this is our second row and third row element. Now to reduce it into row echelon form, what is the row echelon form? It states that the number of 0 preceding the first non-zero entry increases row by row till we have a 0 row. So you can see here the first row having no zero entry. In the second row, we have a 2 0 entry. So in the third row, we are expecting at least a 3 0 entry. So we'll try to make this entry as a 0. But for the same, what can we do? So we'll try to make this element as an identity, because you can see here the second row 4 is common throughout. So we are going to apply the operation R2 by 4. Otherwise, we can interchange these two rows also. Okay, because already this entry is 1. So if we apply this operation, then we'll get 2 1 0 1 0 0 1 1. Now we can apply the operation. Now to make this entry 0, we can apply the operation R3 minus R2. So if we apply this operation, then this is 2 1 0 1 0 0 1 1 0 0. Now 1 minus 1 is 0. 1 minus 1 is again 0. Now clearly it is a row echelon form, because the number of 0 preceding the first non-zero entry increases row by row. Here we have a 2 0, here we have a 4 0. Okay, so which is a row echelon form, which is a row echelon form. And if a matrix reduces into row echelon form, then the rank of a matrix is equal to the number of non-zero rows we left with. So number of non-zero rows in the above matrix. So in this case, how many non-zero rows you can see here? This is non-zero, this is non-zero, because non-zero row means at least one of the entry is non-zero. So here all the elements are 0, so it is a 0 row. So how many non-zero rows are there? It is 2. So which shows that the rank of a matrix is 2. So the correct answer is option C. So in this case, the rank of a matrix is 2 only. Okay, now let us move to the next question. The next question is, we are given a set of vectors, and it is already given that the set of vectors is linearly dependent, and we are interested to find out the value of x. Now in this case, if we want to find out that what is the value of x, what can we do? So firstly, we'll try to check from the given option. Okay, so suppose we put here x equal to 0, then we get entry as 0 6 0. If we put 1, then we get 1 6 1. If we put 2, then it is 2 6 2. And if we put 3, then it is 3 6 3. Okay, so the first thing is, if we just look at these three vectors, so in the first vectors, you can see here the first and the third entry is same. Okay, and even in this particular vector also, the first and the third entry is same. So if I make this entry as a 6, how can we make this entry 6? If we multiply this element with a 3, so if I multiply it with 3, then it is 6. Then automatically your first entry is 3, and the last entry is also 3. 3 6 3. So in that case, this vector is proportional to this one. Automatically, the vectors are linearly dependent. Okay. So in this case, according to this, your correct option should be option D. Okay. But let us see. Otherwise, if we want to find out what is the value of x, then what is the rule? So the first step is, what can we do? We can construct a matrix. If the vectors are given in a row form, then we can construct a matrix in which we arrange the vector row wise, right? V1, V2, V3, if the vectors are given in a row form. Like here we are given vectors in the column form. So we can consider vector as V1 as, say, 1, 2, 1 transpose, V2 as X, 6, X transpose, or V3 as 3, 4, 2 transpose. Okay, so either we can arrange in a column row wise or in a column wise, but in this case the vectors are given in a column form. So in that case we can arrange them v1 v2 and v3. Okay, and we find out the rank of this matrix. So what is the criteria? The criteria is, if the rank of a matrix is equal to the number of vectors, then we say that the vectors are linearly dependent. And if the rank of a matrix is less than the number of vectors, then the vectors are linearly independent. Okay. If we can use the definition of a rank of a matrix also, if we are given a square matrix, right, then the rank of a matrix is equal to the order of is the highest order non-zero minor. Basically, it is a highest order non-zero minor is equal to the order of the highest order non-zero minor. Okay, and if the rank of a matrix is less than the order of a matrix, it means that the determinant of a matrix is zero. Okay, so in this case, we can use the definition of the rank of a matrix. So it means that if the vectors are linearly dependent, then the rank of a matrix should be less than the order of a matrix. What is the order of a matrix? It is 3 cross 3. So it means the rank of a matrix should be less than 3. And if the rank of a matrix is less than 3, it means that the determinant of a matrix is equal to 0. Okay, if the rank of a matrix is less than 3, it means that the determinant of a matrix is 0. So what can we do? We simply find out the determinant of a matrix. So what is the matrix here? It is 1, 2, 1, x, 6, x, 3, 4, 2. Okay. So we find out the determinant of a matrix. So the determinant of a matrix is 1, 2, 1, x, 6, x, 3, 4, 2. So if we expand it through, say, first row. So first row, then the first element is 1 into minus 1 raised to the power 1 plus 1. Exclude this row and this column. So we have a 6, 4, x, 2. The second element is x and its position is minus 1 raised to the power 1 plus 2. First row and second column. If we exclude first row and second column, then we get a minor as 2, 4, 1, 2. And the third one is 3 and its position is minus 1 raised to the power 1 plus 3, and we exclude first row and third column, then this is 2, 6, 1, x. Okay, and if we calculate its determinant and we equate it with 0, okay, let us see that what is the value of this determinant. Okay, we'll try to calculate here. So what is the value of determinant of a comes out to be? So the first one is 1, and if we solve this, this is 12 minus 4x, 12 minus 4x. This is minus x time 4 minus 4, and again it is 3 time. This is 2x minus 6, 2x minus 6, and it is equal to 0. So here you can see 4 minus 4 is 0. So 12 minus 4x. So it is 12 minus 4x plus 6x minus 18 equal to 0. So 12 minus 18 is minus 6 plus minus 4 plus 6x is 2x equal to 0. So from here the value of x comes out to be 6 by 2, that is 3. So you can see here the value of x comes out to be 3 only. Okay, so you can use any one of the concept, especially when you have a MCQ type problems. You need to find out the correct option from the given option only, right? So in that case, you can directly get an idea. If we look at here, because the first and the third element is same, which is same in the first vector also. So automatically you can get an idea that the correct option will be 3 only. But otherwise, you can use the concept that either you can find out the rank of a matrix, reduce it into row echelon form, and then because the vectors are linearly dependent, then you can use the concept that rank of a matrix should be less than 3. Or you can use the definition of a rank of a matrix, that if the rank of a matrix is less than the order of a matrix, it means that the determinant of a matrix should be 0. Okay. Okay, let's fine. Let us move to the next question. Okay, so in this question, we are given a system of equation, And the question is that this system has a unique solution, no solution, infinite number of solution, or five solution. So if you just look at here, in this case, we are given a homogeneous system. Homogeneous system is of the type AX equal to 0, right? And when we discuss about the consistency, then we know that homogeneous system is always consistent. Homogeneous system is always consistent, is always consistent. That means either it has a unique solution or it has infinitely many solutions. So it means that definitely option B and option D is not the correct one. So either you have a correct answer as option A or option C. Now what we need to do in case of homogeneous system, we consider the coefficient matrix A. What is the coefficient matrix A? It is 2, 1, 1. Here the coefficient of x1 is 0. The coefficient of x2 is 1. The coefficient of x3 is minus 1. The coefficient of x1 is 1. Coefficient of x2 is 1. And the coefficient of x3 is 0. Okay. And your unknown x is x1, x2, and x3. So you can see here if we multiply 2x1 plus x2 plus x3 is equal to 0, it is the first equation. 0x1 plus x2 minus x3, second equation. X1 plus x2 plus 0x3 equal to 0 is the third equation. Sorry. So if we want to check that either this system has a unique or infinitely many solution, the concept is we find out the rank of a matrix. If the rank of a matrix is equal to the number of unknown, that means if it is equal to 3, then this system has a unique solution. Then the system has a unique solution, which is also said to be trivial solution. Trivial solution means all the variables are 0. And if the rank of a matrix is less than the number of unknown, that means if it is less than 3, maybe 2 or maybe 1, then this system has infinitely many solutions. Okay. So basically the concept is we need to find out the rank of a matrix A. So let us consider here matrix A is 2, 1, 1, 0, 1, minus 1, 1, 1, 0. Now to find out the rank of a matrix, again there are two ways, right? The rank of a matrix is equal to number of unknown means the determinant of a matrix is non-zero. The rank of a matrix is less than number of unknown means the determinant of a matrix is 0. So either we can find out the determinant of a matrix or we can reduce it into row echelon form. So we can apply any technique to get the answer in this case. Okay, but let us try to find out the rank of this matrix, and so I'm trying to reduce this matrix into row echelon form. So for the same, the first step is we try to make the first element as 1, which is already there in a third row. So we apply here the operation R13. So if we use this operation, now your first row elements are 1, 1, 0, 0, 1, minus 1, and 2, 1, 1. Now to reduce it into row echelon form, so already this entry is 0, so first attempt is to make this element 0. So it is 2, so this is 1, so 2 minus 2 is 0. So we can apply here the operation R3 minus 2R1. So because if we apply 2 times, this is 2, this is 2, this is 0. So if we apply this operation, then your matrix now reduces to, let us consider it here, then your matrix now reduces to no change in the first row element, 1, 1, 0, 0, 1, minus 1. So 2 minus 2 is 0, 1 minus 2 is minus 1, and 1 minus 0 is 1. Okay. So now the next step is we want to make this entry 0 to reduce it into row echelon form. Okay. Because row echelon form is number of 0 preceding the first non-zero entry increases row by row. So if here we have a 1 0 before the first non-zero entry, and in the next row we are expecting at least 2 0. Okay, so we apply here the operation R3 plus R2. That means we are applying operation on third row. So when we apply this operation, now it is 1 1 0, no change in the first row. 0 1 minus 1, no change in the second row element, but third 0 minus 1 plus 1 is 0, 1 minus 1 is 0. Now clearly it is a row equivalent form, which is the row equivalent form. And here the rank of a matrix is equal to the number of non-zero rows. Sorry, number of non-zero rows, which is equal to 2. And definitely it is less than 3. That is the number of unknown. So it means that if the rank of a matrix is less than number of unknown, the system has infinitely number of solutions. So it means that the correct answer is option C. I hope the concept is clear to all of you. Okay, now let us move to the next question. Okay, again in this case, in this question we are given a system of equation. The question is which of the following is true regarding its solution. The system has a unique solution. The system will have infinitely many solutions. Whether or not a solution exists depend upon the given P1 and P2. The system would have no solution for any value of P1 and P2. Okay, the first thing is if you just look at this system, this is the non-homogeneous system of the type Ax equal to B. Okay, and in case of non-homogeneous system, firstly, we can say that a system is consistent or inconsistent, depend that what is the rank of the augmented matrix and what is the rank of A. If the rank of the augmented matrix equal to rank of A, then we say system is consistent. Then further there are two possibilities. Either it is equal to the number of unknown or rank of the augmented matrix equal to the rank of the matrix A, but it is less than number of unknown. Sorry. So in these two cases, we say the system is consistent. Consistent means in this case we have a unique solution. In this case we have a infinitely number of solutions. And if the rank of the augmented matrix is not equal to the rank of a matrix A, not equal to the only case if the rank of the augmented matrix is less than the rank of A, right? Then we say that system is inconsistent and it has no solution. System is inconsistent and it has no solution. Now, if we just look at here system, here the number of unknowns are 3. Number of unknowns are 3, and there are two equations. So definitely the rank of a matrix cannot be equal to the number of unknowns. So it means that the first option is not possible. Second thing is that the rank of the augmented matrix is less than rank of A. Okay, firstly, what is the augmented matrix? So here matrix A is the coefficient matrix, that is 1, 2, 2, 5, 1, 3. And your unknown matrix X is X, Y, Z. And here the non-homogeneous part is B1 and B2 unknown constant. So you can see here the second row is not proportional to the first row. So it means that definitely the rank of a matrix is equal to 2. If the rank of a matrix is equal to 2, then the rank of the augmented matrix is also 2. So it means that the rank can never exceed the, it can never be equal to the number of unknowns. So it means that according to this, the correct answer will be the system has infinitely number of solutions. That means the correct option should be option B only. So this you will get idea directly from the given system only, because there are 3 unknown and we have two equations. So definitely it has a infinite number of solution or no solution. But no solution is possibility only if the second row is proportional to the first one. And in that case, if B1 is not equal to B2, okay, or B1, or after applying this operation, that is B2 minus 5 times B1 is not equal to 0, then this system has no solution. But otherwise, the system has infinitely number of solutions. Okay, let us see otherwise. So firstly, we are considering the augmented matrix, A augmented B. So one side we are considering the matrix A, other side we are considering B1 and B2. Okay. Now to reduce it into row echelon form, we are going to apply the operation R2 minus 5 times R1 because I want to make this entry 0 and already this entry is 1. So if we apply this operation, 1, 2, 2, 5 minus 5 is 0, 1. Now, if we apply R2 minus 5 times R1, this is 5, this is 10, this is 10, and this is 5 times B1, right? So 5 minus 5 is 0, 1 minus 10 is minus 9, 3 minus 10 is minus 7, and this side, this is B1, this is B2 minus 5B1. So clearly, it is a row echelon form. It is a row echelon form, and so the rank of the augmented matrix and the rank of the matrix A, because it has the two non-zero rows, so the rank of A is 2, and because the rank of A is 2, the rank of augmented matrix is also 2. Either this entry is 0 or non-zero, it doesn't matter. Okay, so it means that, but it is less than the number of unknown, because the rank of these two is equal to 2, which is less than 3, that is the number of unknown. So automatically this system has infinite number of solutions. Hence the correct answer is option B only. Okay, fine. Let us move to the next question. Okay, in the next question again we are given a system of equation. In this case it is already given that your system is consistent and we want to find out the relation of A, B and C. Okay, let us see. So, like I already told you, system is consistent means that if it is a non-homogeneous system, then the condition is the rank of the augmented matrix is equal to rank of A. So let us firstly consider the matrix A. Here the matrix is the coefficient matrix, which is 1, 2, 3, 2, 3, 3, 5, 9, minus 6, and the unknown is X, Y, Z, and your unknown non-homogeneous is A, B, and C. So firstly, we are going to consider the augmented matrix A augmented B. So one side we are considering matrix A 1, 2, 3. Sorry, it is minus 3. 1, 2, minus 3. 2, 3, 3, 5, 9, minus 6. And here A, B, C. Sorry. So now to reduce it into row echelon form. So already this entry is 1. So to make these two elements 0, firstly we need to make this entry 0. So we are going to apply operation R2 minus 2 times R1. So 2 times means this is 2, this is 4, this is minus 6, and this is 2A. So if we apply this operation, then this is equal to, no change in the first row, 1, 2, minus 3. This is 2 minus 2 is 0. 3 minus 4 is minus 1. 3 plus 6 is 9. And here it is A, this is B minus 2A. And now the next one is, here we have a 5, so the operation will be R3 minus 5 time R1. Okay, because here we have entry 1, 5 minus 5 is 0. We apply this operation, then this is 5, this is 10, this is minus 15, this is 5a. Okay, so 5 minus 5 is 0, 9 minus 10 is minus 1, minus 6 plus 15 is again 9. This is C minus 5a. Now to reduce it into row echelon form, so the next step is I want to make this entry 0. So here minus 1, this is minus 1. So we can directly apply the operation R3 minus R2. So if we apply this operation, 1, 2, minus 3, 0, minus 1, 9, B minus 2a, no change in the first two rows, and here 0, minus 1 plus 1, 0, 9 minus 9, 0. Now C minus 5a minus B plus 2a. So this is C minus B minus 5 plus 2 is minus 3a. C minus B minus 5 plus 2a. So this is the matrix reduces into row echelon form. Now you can see here third row is 0. If this entry is non-zero, then your system is inconsistent, because in that case rank of the augmented matrix is not equal to rank of A. So the rank of the augmented matrix is equal to rank of A only if this is 0. So system is consistent system is consistent if C minus B minus 3a equal to 0, or I can say 3a plus b minus c equal to 0, because 3a and b, they are of same sign. If we take negative sign common, then these two become positive and the c is negative. So the correct answer is option B only. Okay, so what is the condition here? We are given that system is consistent. It means that the rank of the augmented matrix is equal to the rank of a matrix A, and hence we come out with this solution. Okay, now let us move to the next problem. Okay, so here we are given the eigenvalues and the corresponding eigenvector of the 2 cross 2 matrices are given by lambda 1 and lambda 2, and the eigenvectors are given. So the question is, we want to find out the matrix A. So here the eigenvalues and the eigenvectors of a matrix A are given. So we are interested to find out the matrix A. So what can we do? Okay, the first thing is, uh, because it is just a 2 cross 2 matrix, otherwise we can use the concept of diagonalization. According to the concept of diagonalization, we can say that a matrix is diagonalized if there exist the linear independent eigenvectors, okay, such that there exists a non-singular matrix that P inverse AP is equal to D, where D is the diagonal matrix, where the diagonal elements are the eigenvalues of a matrix A. Or we can say that A is equal to PD P inverse. This is the case if we are given a higher order matrix, because we are already given the 4 options. So we'll try to judge the correct option with the help of the properties of eigenvalue and eigenvector only. So what is the property? The first one is the determinant of a matrix is equal to the product of the eigenvalues. Product of the eigenvalues, and the trace of a matrix A is equal to this sum of the principal diagonal element. Sum of the principal diagonal element is equal to the sum of the eigenvalues. Equal to the sum of the eigenvalues. Okay, so if we use these two property only, so what is lambda 1 plus lambda 2? Sum of the eigenvalue is 12, and the product of the eigenvalue lambda 1 into lambda 2 is 8 into 4 is 32. Okay, so if we Just look at the option. In the first option, the sum of the diagonal element is, if we look at the sum of the diagonal element, 6 plus 6 is 12, and 6 into 6, 36, minus 4 is 32. So if we consider A as 6, 2, 2, 6, so you can see here the determinant of A is 36 minus 4 is 32. Here it is also 32. And the trace of A, that is the principal diagonal element sum, is 12, which also satisfies this condition. So it means that the correct answer is option E. But still, if we want to verify, then we can use the condition that Ax is equal to lambda x. What is A? 6226. If we multiply it with x, say V1, 1, 1. So this is equal to 6 plus 2 is 8, 2 plus 6 is 8. So this is 8 times 1, 1. So AV1 is equal to 8 times V1. Satisfy the first condition. And if we consider second one, that is AV2 equal to, A is 6226 and V2 is 1 minus 1. And this is 6 minus 2, and here it is 2 minus 6. This is equal to 4, and here we have minus 4. And if we take 4 common, 1 minus 1. So what do we get here? AV2 equal to 4 times V2. So it means that 4 is the eigenvalue corresponding to this eigenvector, 8 is the eigenvalue corresponding. So the correct answer is option A. Okay. So with the help of these two property, because we are already given the 4 options, so we can easily judge that which of the option is correct one in this case. Okay, let us move to the next question. Okay, again the question is based on eigenvalue and eigenvector. So we are given a matrix A. One of the eigenvalues is given as 3, and we want to find out the other two eigenvalues. Okay. So again, we can use the property of eigenvalue and eigenvector. So what is the property? The trace of A is equal to the sum of the eigenvalues. Sum of the eigenvalues. So what is the trace of A? This is 2 minus 1 equal to 1. That means if one of the eigenvalue is 3 and other two are, say, lambda 2 and lambda 3. So lambda 2 plus lambda 3 is equal to 1 minus 3, that is minus 2. And also, what is the determinant of A? Determinant of A is equal to the product of the eigenvalues. Product of the eigenvalues. So what is the determinant of A? If we expand through first row, say third row, so we get 1 time, we exclude this row and column. This is minus 2, 3, minus 1, 6. Then minus 2 time, excluding second row, column and third row. This is 2, minus 2, 3, and 6. So this is equal to 1 time, minus 12 plus 3, minus 2 times 12 plus 6. So this is minus 9 minus 18 to the 36. It is minus 45. So product of the three eigenvalues is minus 45. That means lambda 1, lambda 2, lambda 3 is equal to minus 45. But lambda 1 is given as a 3. Lambda 1 is already given as a 3. So what is lambda 2 into lambda 3? It is minus 45 by 3, that is minus 15. So the product of the eigenvalue is minus 15. Sum of the eigenvalue is minus 2. So if we choose 3 and minus 5, what is minus 5 plus 3? Equal to minus 2, and minus 5 into 3 is minus 15. So automatically the correct answer is option B, because it is not possible in this case, because in this case the sum is minus 3, not possible. In this case sum is 7, not possible. In this case the sum is 8, not possible. So the correct answer is option B. Okay, so with the help of the properties of the eigenvalue and eigenvector, we can easily find out the other two eigenvalues. Okay, let us move to the next one. Again, we are given a matrix A, and it is given that it has a three distinct eigenvalues. and one of the eigenvector is 101. Which one of the following can be the another eigenvector of A? Okay, so in this case, there are two ways to find out the other eigenvector. One is we can use the property that Ax is equal to lambda x, right? And the second one is if you just look at this matrix, if you just look at this matrix, so you can see here this matrix is a symmetric matrix because what is A? A is 3 by 2, 0, 1 by 2, 0, minus 1, 0, 1 by 2, 0, 3 by 2. Okay, in case of symmetric matrix, apart from the diagonal element, rest all the element, they the element present in a transpose position, they are same. So like A12 is equal to A21, A13 is equal to A31, and A23 is equal to A32. You can see here they are same. So it means that the given matrix is symmetric. Means in this case the A transpose is equal to A. First row, first column, second row, second column, third row, third column. And in case of symmetric matrix, the property is the eigenvectors corresponding to distinct eigenvector corresponding to distinct eigenvalues corresponding to the distinct eigenvalues. The eigenvectors are mutually orthogonal. Eigenvectors are mutually orthogonal. Okay, what does it mean? It means that x1 transpose x2 is equal to 0. So we'll simply try to identify that vector so that their dot product is 0. Okay, so like 0, 0, minus 1, not minus 1, 0, 0, not 1, 0, minus 1. So it means that this is the correct option because if I choose this one, what is this transpose 1, 0, minus 1? And if we take its product with 1, 0, 1, then the resulting is 1 plus 0 minus 1, it is 0. So it means that this is the correct one. Otherwise, we can verify using this property also. What is A? 1.5, 0.5, 0 minus 1, 0, 0.5, 0, 1.5. If we multiply it with 1, 0, minus 1, what do we get? 1.5 minus 0.5, it is 1, 0, 0, 0. This is 0.5 minus 1.5 is minus 1. So you can see here Ax is equal to 1 times x. In that this is the eigenvector. Okay. So you can use any one of the property. Either you can use the eigenequation that Ax is equal to lambda x. That means when we multiply the eigenvector with the matrix A, it is equal to scalar multiple times the eigenvector. That means x is the eigenvector. Or otherwise, in this case, if you simply observe that the given matrix is a symmetric matrix, and in case of symmetric matrix corresponding to the distinct eigenvalues, their eigenvectors are mutually orthogonal. So we can use this property also. Okay, now let us move to the next question. Let the eigenvalues of 2 cross 2 matrix A be 1 and minus 2 with eigenvector x1 and x2. Then the eigenvalue and eigenvector of the matrix A square minus 3A plus 4A would be. Okay, so here the eigenvalues of matrix A are given as lambda 1 is 1, lambda 2 is minus 2, and x1 and x2 they are x1 and x2 they are the corresponding eigenvector. Okay, so what I want to do, I want to find out eigenvalue and eigenvector of matrix A square minus 3A plus 4A. Okay, so here we use again the property. We know that if Ax is equal to lambda x, then A square x is equal to lambda square x, and alpha times Ax is equal to alpha times lambda x. Okay, or simply we can say that f of Ax, f of A be any polynomial in x, it is equal to f of lambda x, right? You have Hope you have heard about the Cayley-Hamilton theorem, which states that every square matrix satisfies its own characteristic equation, right? So we can directly use this particular result also. Okay, let's suppose that we are considering B as a square minus 3a plus 4i. All right. Then what is bx? So bx means a square minus 3a plus 4i times x. So this is equal to a square x minus 3ax minus plus 4x. So a square x is lambda square x. 3x is means 3 times lambda x and 4x become 4x, or lambda square minus 3 lambda plus 4 times x. Okay, let us suppose that this is mu. Okay, so what is mu? Mu is basically lambda square minus 3 lambda plus 4. So if lambda equal to lambda 1, then mu is equal to mu 1. So what it will be? It is equal to 1 square minus 3 times 1 plus 4. So 1 minus 3 minus 2 plus 4 is 2. And what about mu 2? It is lambda 2 square minus 3 times lambda 2 plus 4. This is minus 2 square minus 3 into minus 2 plus 4. So 4 plus 6 plus 4 is 14. So what are the eigenvalues? 2 and 14. And you can see here ax is equal to lambda x, then a square x is also equal to lambda square x. So it means that if a has eigenvalue lambda and its corresponding eigenvector is x1, so what does it mean? It means that bx1 is equal to mu1 x1 and bx2 is equal to mu2 x2. Okay, so it means that x1 and x2, these eigenvectors will remain same corresponding to the eigenvalue 2 and 14. So the correct answer is option A. Okay, that means when lambda equal to lambda 1, lambda equal to lambda 1, what is x? X become x1. Okay, what is bx1? Bx1 is lambda 1 square minus 3 lambda 1 plus 4 times x1, because x1 is the eigenvector corresponding to lambda 1 and x2 is the eigenvector corresponding to the eigenvalue lambda 2. So like we have written here that there will be no change in the eigenvector if your eigenvalue will remain same. Okay, and if a has eigenvalue lambda, then any function of a, that is polynomial function in a, have a eigenvalue f of lambda, but eigenvector will remain same. Okay, now let us move to the next question. The question is the number of linearly independent eigenvectors of the matrix A. Actually, I have taken this problem from the GATE examination. So if I ask you the in MCQ type, the option may be given like it has a one linearly independent eigenvector, it has a two linearly independent eigenvector, it has a three linearly independent eigenvector, or it has a four linearly independent eigenvector. Okay, so we want to see that which of the, because although we know that if we have a matrix of order 3, it has at most 3 eigenvalues, and corresponding to the distinct eigenvalue, we have a linearly independent eigenvector. Okay, so let us firstly see that how many different eigenvalue we have in this matrix. So now you can see here it is an upper triangular matrix. In case of upper triangular matrix, the diagonal elements are the eigenvalues of a matrix A. So basically the eigenvalues are 2, 2 and 3. But otherwise, if we want to calculate, we can consider the characteristic equation. The characteristic equation of the matrix A is determinant of A minus lambda I equal to 0. A minus lambda I means we are going to subtract lambda from the principal diagonal element. 2 minus lambda 1 0 0 2 minus lambda 0 0 0 3 minus lambda. And if we calculate its determinant and if we equate it to 0, then it will become 2 minus lambda 1 0 0 2 minus lambda 0, 0, 0. 3 minus lambda determinant equal to 0. Now, if we expand through first column, then we can get 2 minus lambda into 2 minus lambda into 3 minus lambda equal to 0. So you can see here lambda is 2, 2 and 3. Now you can see here 2 is repeated 2 times. So if the eigenvalues are repeated, and corresponding to the repeated eigenvalues, how many eigenvectors are possible? That we can calculate with the help of this formula. The number of linearly independent eigenvector, say P, corresponding to the repeated eigenvalue, or corresponding to the repeated, or you can say that associated with the repeated eigenvalue, is given by n minus r. What is n? N is the order of the matrix, and r is the rank of the matrix A minus lambda I. Okay, so let us consider the A minus 2i matrix. So A minus 2i, 2 minus 2 is 0, 1, 0, 0, 2 minus 2 is 0, 0, 0, 0, 3 minus 2 is 1. Now, if we try to reduce it into row echelon form, already here we have a 1, 0, here we have a 2, 0, here it is completely 0. So we can interchange second row with third row. Then it is a row echelon form, 0, 1, 0, 0, 0, 1, 0, 0, 0. So here we have a 1, 0 entry before the first non-zero entry. Here we have a 2, 0 entry, and this is completely 0. So it is already row echelon form. It is already row echelon form. So number of non-zero rows, the number of non-zero rows equal to 2. So the rank of A minus lambda I, that is A minus 2i, is equal to 2. So if what is the order of the matrix? Order of the matrix is 3. So therefore P is equal to n minus r. 3 minus 2 is equal to 1. So it means that it has a one eigenvector corresponding to these two eigenvectors. And one eigenvector will get corresponding to 3. So the total number of linearly independent eigenvectors are 1 plus 1, that is 2. So the correct answer is 2, that is B is the correct answer. Okay. Otherwise, the simple rule is corresponding to the distinct eigenvalues, we have a linearly independent eigenvector. Means if all the eigenvalues are distinct, then if say here the eigenvalue is 2, here I can consider 1, then 2, 1, 3 means all the eigenvalues are distinct, then it has a 3 linearly independent eigenvector. But because one of the eigenvalues is repeated, so corresponding to the repeated eigenvalue, we may have one or more than one linearly independent eigenvector. It depends on the rank of the matrix. Okay, so because the rank of a matrix comes out to be 2 and n minus r it is 1, so it means that corresponding to this repeated eigenvalue, we have only one linearly independent eigenvector. 1 plus 1, total 2 linearly independent eigenvectors. Okay, now let us move to the next question. The question is the characteristic equation of matrix P is defined as this. If I denote the identity matrix, then what is the inverse of a matrix P? Okay, so here we are given the characteristic equation and we are interested to find out the inverse of a matrix P. So whenever the question is about that, we will try to find out an expression of a matrix A in term of the matrix A or some power of matrix A or polynomial in matrix A, we can use Cayley-Hamilton theorem. We can use Cayley-Hamilton theorem. This theorem states that every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. So what does it mean? It means that if, like in this case, the characteristic equation is lambda cube plus lambda square plus 2 lambda plus 1 equal to 0. And according to the Cayley-Hamilton theorem, it means a cube plus a square plus 2a plus I equal to null matrix, because now this polynomial converted into a polynomial in matrix. So this scalar quantity converted into scalar matrix. So here it is 1, so it means it become identity matrix. Now because this constant term is non-zero, so it means that A inverse should exist. Okay, if this constant term is non-zero, that means A inverse exists. So we can operate A inverse throughout. So we get A inverse time A cube A square plus 2 times A plus identity matrix equal to A inverse time null matrix. So we'll get A square plus A plus 2 times identity matrix plus A inverse equal to null matrix. So A inverse, it will be equal to minus of A square plus A plus 2 times. Okay, here we are given a matrix P. So it means that if P is a matrix, then the expression should be P inverse equal to P square plus P plus 2 times identity. So the correct option will be option D. Okay. So here we can simply use the Cayley-Hamilton theorem to get the solution of this problem. Okay, now let us come to the next question. So in this case, we are given a matrix A, and the question is that we need to find out the top row element of R inverse. Okay, if the question is simply to find out the element of the top row, that means we are interested to find out the element of this one. Okay, so what can we do? We can directly use the definition that what is A inverse? A inverse is equal to adjoint of A upon determinant of A, right? And otherwise, uh, there is another method to find out the inverse of a matrix is the Gauss-Jordan method, where we can consider the A augmented I matrix, where one side we are considering matrix A, other side we are considering identity matrix, and we'll try to reduce this matrix into I. So as soon as this matrix reduces to I, this matrix will become A inverse only. Okay, so I'll try to show you by both the method, because sometime in this case we are directly given the matrix A. Sometime matrix are not given. Sometime we are given the expression in this form also. Okay, like after some elementary operation we are given a matrix, and the question is that we need to find out the element of A inverse. Then we should know that how can we find out the inverse of a matrix in that case, right? So I'll try to solve in both the way. So here we are considering one side the matrix R, other side we are considering the identity matrix of same model. So we'll try to reduce this matrix into identity matrix. So for the identity matrix, firstly we need to reduce it into row echelon. Okay. So already this entry is 1. So we'll try to make these two entries 0. So we are applying operation R2 minus 2R1 and R3 minus 2R1. So this becomes 2 0 minus 2. This becomes 2 0 0. And what do we have? 1 0 minus 1, no change in the first row element. The 1 0 0. This is 2 minus 2 is 0. 1 minus 0 is 1. Minus 1 plus 2 is 1. 0 minus 2 is minus 2. This is 1, 0. Again 2 minus 2 is 0. 3 minus 0 is 3. 2 plus 2 is 4. And this is minus 2. This is 0 and 1. Now to reduce it into coequivalent form, we'll try to make this entry 0 by applying operation R3 minus 3 times R2. So if we apply this operation, then this is 1 0 minus 1. This is 1 0 0 0 1 1 minus 2 1 0 0. 3 minus 3 is 0. 4 minus 3 is 1 minus 2 plus 8, because when we are taking 4 times, so basically this will be minus 8 4 0. Sorry, 3 times. It is 3 times. So 3 times means it is minus 630. So minus 2 plus 6 is 4. 0 plus 3. Okay, 0 minus 3 is minus 3 and 1 as it is. Now, because you can see here it is a row equivalent form, the rank of this matrix is 3. It means matrix A is invertible. Now, to reduce it into identity matrix, we need to make these two entries 0. So we can apply operation R1 plus R3 minus 1 plus 1 is 0 and R2 minus R3. So if we apply this operation, then we can get here as 1 0 0 0 1 0 0 0 1, and this side R1 plus R3, 1 plus 4 is 5 is minus 3 and 1. R2 minus R3, minus 2 minus 4 is minus 6, 1 plus 3 is 4, minus 1, and this is 4 minus 3 and 1. So because this is identity matrix, so automatically this matrix is R inverse. So the first row element is 5 3 minus 1. This is the correct option. Okay, so here you can use also adjoint of A. Adjoint of A is nothing but a matrix in which we are having the element as a cofactor A11 star, A12 star, A13 star, A21 star, A22 star, A23 star, A31 star, A32 star, A33 star, and we need to find out the transpose of this matrix. Transpose of this matrix means the first column, the first row become A11 star, A21 star, A31 star. So we need to find out the cofactor of A11, which is 2 plus 3, 5. So A11 star is 5. A21 star, this is equal to 0 plus 3. It is 3, but with minus sign, minus 1 raised to power 2 plus 1 times 3, so it is minus 3. And A31 star, this is equal to, write this one, so it is 0 plus 1, 1 into minus 1 raised to power 1 plus 3, it is equal to 1 only. And what is the determinant of R? Determinant of R is, we expand through first row, 1 into 2 plus 3 is 5, then 0, then minus 1 time 6 minus 2 is 6, minus 2 is 4. So 5 minus 4 is 1. So it is 1 time 5 minus 3 and 1. So in that case also you can get the answer. So it's your choice. Either you can apply Gauss-Jordan method, where you can get the complete information about the inverse of a matrix. Or if you are interested in only one row or one column of a matrix, then you can apply this definition also, if you have a complete information about the matrix. Okay, now let us move to the next question. Okay, in the next question, we are given a 3 cross 3 matrix P such that P cube equal to P. Then what are the eigenvalues of P? So again, if you look at here, we are given one equation that P cube is equal to P. So if we are interested in eigenvalue and eigenvector, we know this relation that Ax is equal to lambda x. So Px is equal to lambda x, and also P cube x is equal to lambda cube x. This is the property of the eigenvalue and eigenvector. But P cube is equal to P, so it means that Px is also equal to lambda cube x. So if we consider the first and the second equation, we can get lambda cube x equal to lambda x, or lambda cube minus lambda x equal to null matrix. Obviously, x should not be equal to null matrix, so it means that lambda cube minus lambda, it should be 0. So lambda into lambda square minus 1 equal to 0. So the value of lambda is 0 or plus minus 1. So the eigenvalues are 0 and plus minus 1. Okay. So basically, again, here we can use the concept of Cayley-Hamilton theorem also. If P cube minus P equal to 0 is the null matrix, then lambda cube minus lambda is equal to 0. Okay. So it shows that one of the eigenvalues should be 0 because there is no constant term. If one of the eigenvalues is 0, then this is the only possible option, because in other all three options we have one non-zero eigenvalue. Okay, or otherwise you can use the eigenequation. Whenever you have a problem based on eigenvalue and eigenvector, most of the problem we can solve with the help of this eigenequation only. Okay, move to the next question. Okay, again we are given a matrix A and identity matrix, and we are interested to find out A cube in term of A only. I already told you, whenever the question is based on that, we'll try to express a matrix A in term of a polynomial in matrix A, then we have to use the Cayley-Hamilton theorem. Okay, so what can we do here? We simply write the characteristic equation A minus lambda I equal to 0. And in case of 2 cross 2 matrix, the characteristic equation is, we can directly write the characteristic equation as lambda square minus trace of A time lambda plus determinant of A equal to 0. Sum of the eigenvalue is equal to trace of A. Product of the eigenvalue is equal to determinant. Okay. So what is lambda square minus what is trace of A? Sum of the principal diagonal element, it is minus 5. And the determinant, it is 0 plus 6. It is 6. So that is lambda square plus 5 lambda plus 6 equal to 0. So according to the Cayley-Hamilton theorem, we have A square plus 5A plus 6 times I equal to 0. Or we can say that A square equal to minus 5A plus 6 times I. And we are interested to find out A cube. So to get A cube, I simply operate with A. So it is A cube equal to minus 5 times A square plus 6 times A. And again, what is A square? Again, we use this result here. A square is minus 5 times A minus 6 times identity matrix minus 6 times A. So this is 25A plus 30I minus 6A. So 25 minus 6 is 19A plus 30I. So the correct answer is 19A plus 30I. What is the value of A cube? A cube is equal to 19 times A plus 38. Otherwise, you can find out A cube also, and you can check its value by any of the solution, but it is a tedious job in that case, right? Although in this case, the two options are same, but in this case, the correct answer is this one. Okay, so these are some MCQ type problems based on the linear algebra. I'll try to consider some problem based on the this particular topic, and I have taken this problem from the GATE examination, which are these standard problems. Okay, so I hope if you will practice this problem, you can get an idea that how can we solve the MCQ type problems based on these topics. Okay, so soon I'll try to share with you the MCQ type problems based on differential equation also. Thank you. That's all from my side.